Let's talk about how to graph the basic cosecant theta function. And in order to do that, we're going to recall that cosecant theta is actually 1 divided by sine theta. That's the definition of a cosecant. So it's closely related to the graph of sine theta. So in order to graph cosecant function, we're going to graph sine function first, and we're going to use it as a guide to graph out cosecant function. So let's start. We know that sine theta is 0 at 0, and then it reaches its maximum at pi over 2, and then it goes to 0 at pi and reaches its minimum at 3 pi over 2, and then back to 0. So this is a one cycle of the, and then we can extend it, of course, to the other side. Just draw a couple more cycles of it. Just actually one more. All right, so there we go. There we go. Okay, so the cosecant function is 1 divided by sine, just like we mentioned. So what happened in the points where sine value equals 0? Well, we know that division by 0 is undefined, and therefore the function is undefined for those points. So when sine function hits 0, we an asymptote, right? So we have an asymptote that happens at 0, pi, 2 pi, negative pi, negative 2 pi, so forth. So those are our asymptotes. Okay, so let's the asymptotes are actually parts of the cosecant graph. Now, the sine is just a guide. Okay, so sine value at pi over 2 is 1. So what's the cosecant value? 1 over 1 is 1. So now this point is part of our cosecant graph. Now, at 3 pi over 2, sine value is negative 1. What's cosecant value is 1 over negative 1 is going to be negative 1. And same for these minimums and maximums as well. Now let's see what else. Well, we know that a sine value at pi over 6 is half. So what's the cosecant value? 1 divided by half is going to be a 2. So that's going to be value on the graph, point on the graph of cosecant function. So same happens here in this point. And then we're going to basically on for 7 pi over 6, so 1 divided by negative 1/2 is going to be negative 2. So these points are also points on the graph of the cosecant. Now let's connect those points, and we have our graph of a sketch of a cosecant graph. Right there, right there. All right. So here we are. This is our cosecant graph along with the asymptotes. Don't forget the asymptotes are parts of the graph as well. All right, so start with graphing a sine function as a guide, and then graph cosecant using that guide. Now let's take a look at how we're going to graph a secant function. its secant function is 1 over cosine theta. So we are going to start by sketching a cosine theta function. So in order to do that, we know that a cosine has its maximum at 0 and it has its minimum at pi. And then it repeats itself on both sides. It's an even function right here. Okay, so and it goes through zeros at pi over 2. And 3 pi over 2. So this is one cycle of cosine function. Of course, it extends out into both directions like this. All right. So we have this function sketched. So we're going to apply the same reasoning that we applied when we were drawing the cosecant function. Whenever cosine equals 0, that's where our function is going to have an asymptote. Is going to be pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2, and so forth. We extend it, instead extending infinitely in both directions. Now, again, the highest point of cosine is 1. So 1 divided by 1 is going to be 1. And the lowest point is negative 1. So negative 1 divided by negative 1 is negative 1. So these are also the points on the secant graph. And then for the cosine value equals 1/2 when theta equals a pi over 3. So it's 1/2 here. So when we divide 1 by 1/2, the value is going to be 2. Same at negative pi over 3. So our secant function will go like this here. And so for 2 pi over 3, the function value is negative 1/2. So 1 divided by negative 1/2 of negative 2. 4 pi over 3, same thing. So this is how our graph of the secant function is going to look here. And of course, we're going to extend this reasoning, and there you go. This is our graph of a secant of the function secant theta.